What is up, everyone? I am going to try to not talk too loud because there are people asleep, but I'm wanting to do this video because Marshall has asked to sit down and kind of go over how I suddenly went from, I want to pick up 3D modeling to, hey, can you print stuff off for me? So I'm going to redo a design that I did last night. I think it took me about 2 hours last night. I'm going to try to get it down to below an hour, but we will see. This is ultimately what we're going to recreate. Let me turn the body back on for you real quick, and we can hide sketches. We don't need those. So I turned this into a 3D printable model from a picture that looks like this. So this is what I had to go off of. This is a metal plate, and I took this, or I took the metal plate and I made a copy of it. Literally, I put it on a photocopier, put a white sheet of paper behind it, and then made a copy of the plate. And I went back with a pair of mics and I measured what I thought was everything. There are several things that I didn't measure out correctly, but like I forgot to locate these holes. You know, there is no location from this sidewall over here to this first hole. There's no location for this hole to this sidewall, which was kind of an oversight on my part when I went to go measure everything. I literally measured everything, but not their locations, which is a bit of a problem. So I was able to get around that last night. I somewhat remember what my measurements were from last night when I did this model initially, but the other thing that I did is these numbers are very vague. This was not a CAD model or a drawing that was approved by anybody. This was just me taking a pair of micrometers and measuring something that was already in existence. And not only was it already in existence, but it had been used for a while. I'm sure you can see that the wear on the metal plate is there. It's very obvious in places. So when you go to measure the inside diameter of a hole, hello, Alina. When you go to measure the inside diameter of the hole, I'm measuring it by hand with a pair of digital micrometers. So, yes, I was able to see what the digital readout of the micrometers was, but it's not precise. When you get a CAD drawing from a supplier, a manufacturer, a client, whoever, they're going to have very precise measurements, and I just didn't have that with this drawing. So there's going to be a few times where the numbers are going to change. I think just above this line right here, I actually wrote a thickness that is impossible. This is a step right in here, and we can see that step again right here. So you see this area right here where the mouse is on, that's a sidewall right there, and then that's the top surface. The white area in the back would be the bottom, but there's actually a step right here, and then the width of that step, and then this sidewall and the height. Well, from the white space in the back, which would be the bottom, actually the surface that we're seeing is the bottom, but it didn't get measured that way. This plate was sitting on a table, and I measured the distance from the table to this first step at 3.4 millimeters, and then the distance from this step to the top of the plate measured at, what did I have written here? 9.34 millimeters, which, you know, whatever. But that's a total of 12.74 millimeters. When I mic'd the plate out, I measured the thickness of the plate at 12.4 millimeters. So we already have a math problem right here. So, like I said, you know, this is a little bit different from a professional drawing that would be submitted for or to a machine shop saying, "Hey, make this," or CNC this. So going from, you know, here's a metal plate, you need to make a copy of this, to actually creating a 3D model that I can actually print was interesting. And so it gave me a little bit of liberty here and there, but like I said, I really messed up when I did my initial drawing. I didn't locate the distant or these holes or this hole. Everything, this whole design, this pattern right here, locates off this center hole, and I have the specifications for that for these locations, but I didn't locate this hole to a sidewall, and I didn't locate either one of these holes to a sidewall. So I screwed up in those areas, but that aside, some of the things that we can look at are, one, as you saw in the in the actual produced product, the plate itself is the plate that I copied was a rectangle, but the drawing is of a square, and this has to do with the size of the build plate of the 3D printer that I am using. We are going from, this is a metal object, and we're going to a 3D printed plastic object. So the size of the build plate dictated that this area right here that's not used for anything get cut off. So that changed our shape a little bit, but obviously I have to leave a gap for, or I have to leave space for these two holes. So I was able to fit that in. There were a few changes that were made to the initial design so that I could make it possible to actually print it, but work wanted to make make at least one more of these plates, and having this CNC'd would cost a decent amount of money. Not really anything that my company would notice, but it would be more expensive than, say, 3D printing this. So this was kind of a trial as to, hey, can we actually do this kind of stuff in-house? What will the end result be? And is this something that we can reproduce? Is it going to be a fun trial that maybe one of our employees thinks he can do, or can we actually recreate things and reproduce them in-house without having to spend as much money? And that's really one of the advantages of a 3D printer, is, you know, we have a lot of plastic components where I work, and a lot of those can actually be 3D printed. So this was something that I threw up towards management and said, hey, let me do this. And, you know, that way we can, it's X amount for this metal plate to be CNC'd, and it's X amount, which is significantly smaller, if we 3D print it with what we already have in-house. My work already has a 3D printer, and we already had filament, so that's enough prelude, I think. I'm going to move this off screen where I can still see it, but I will definitely reference it. How about I collapse it? There we go. I will definitely reference it as I am going. So yeah, I think that's about it. Nope, I need that one still open. I'm going to go ahead and close this drawing, so I won't be copying or pasting anything. We're going freehand from here. So my measurement for the width was about 6 inches, and with a rough conversion, we're talking 6 by 25. So if we want to go from a standard or imperial measurement of 6 inches, and we want to convert that into the metric system, It's 25.4 millimeters to an inch. So we'll drop the 0.4 off. We'll multiply 25 by 6, and that gives us with 100, or that leaves us about 150 millimeters. The 0.4 by 6, I mean, we can get an extra 2.5 millimeters out of that if we really need to. Yes, sorry, 2.4 millimeters out of that if we really want to, but it's really not that critical. There's more than 2.4 millimeters on the sides, so I'm not too concerned. So anyways, what we're going to start with is a top look. When you open Fusion 360, it usually, when you turn the origin on, it usually gives you a view similar to this. I'm going to go to a top view real quick, so it's just going to show me basically what's going to end up being my bottom. I'm going to press S on my keyboard, and then I already have the center rectangle quick link right there, but if we don't have that quick link there, it's just center, and center rectangle is right there, so we can click on that and we'll be able to draw a center rectangle. Now we need to draw a square that's essentially 150, I'm going to say 155 millimeters. I don't remember what number I actually sided with, but we're going to say 150 millimeters. So I'm going to go ahead and move the screen so that I have something that's big enough, and there we go. I have an area that's about big enough, and I'm going to go ahead and draw my center rectangle now. Starting by 75 should be somewhere in this area, but we're not going to leave anything to chance. So 150, oops, that's 140. I'm going to say 155 by 155. So we have our square right here. Now I mentioned before that the thickness of this plate was 12.3 millimeters, or 12.3 or 12.4 millimeters, but I'm going to go ahead and take this actually all the way up to 12.5 millimeters. And so we've extruded that. That was a quick key. The key Q pulls up the push-pull tool or the extrude tool, and I could just grab this right here and pull it out to my desired height, but typing in the number actually produces a better result. So 12.5 millimeters, and now we have our base plate, which is 12.5 millimeters high and 155 millimeters on each side. Now the plate, the original plate that we had, has rounded corners, so I'm going to quickly flip through here real quick and select all 4 of my corners. I'm actually going to hide the origin again real quick. Whoops, wrong button, light bulb. And to multi-select facets, you're going to hold down the control key. So if you want to select all 4 corners, just hold down the control key and you can select as many facets as you need to. I'm going to press the F key on the keyboard for fillet. I could be pronouncing that wrong, and if I am, sorry. It might be fillet. I don't know. I only wrote 4 books. I'm not a grammatical mastermind by any means. So that's a 10 millimeter. Yeah, I think that looks appropriate right there. That's a 10 millimeter fillet. So we're going to go ahead and accept that real quick, and we're going to go back into our top view. Now I'm going to turn on the sketches, which gives me a couple of construction lines to work with, and this actually tells me where the center of my square is. Now I need a little bit more than the center of my square on the X. I need a center of the square on the positive side of things. So I'm going to select, we are in Fusion 360, and you must draw on either a surface or a plane. And it happened again here too, but Um, it says top. I'm drawing on the top, even if for some reason the plane moved to the bottom. Anyways, we have to draw on either a face or a plane, a surface or a plane. So we've selected the top face or top surface of our plate. This triangle is showing me that I am halfway between the top and the bottom, and apparently I already clicked, but whatever, that's fine. That triangle, the blue triangle right next to my icon, is telling me I am halfway between the top and the bottom of the side lines. So I'm just going to run that line across real quick, and while I have the opportunity, I'm going to flip that out. Zoom controls are a little bit backwards on this, but Fusion 360 does give you the option to swap them. I use a trackpad that supports pinch and spread. So for me to zoom, I just like on a smartphone, I put 2 fingers on the trackpad and drag apart or squeeze in. Where on my cell phone, if I put 2 fingers on the screen and drag apart, it's going to make it bigger. In Fusion 360, the default is to actually shrink the object if you put 2 fingers on the trackpad and drag apart. So I don't want this line to show up in my final drawing. So I'm going to select this line real quick and press the X key, and you can see over here construction line is illuminated. I could have just clicked that line. As a matter of fact, if I click the construction icon, it becomes a regular line again, but I do want it to be a construction line, which means that it will not show up in my final product or on the final drawing. So we've got that. I'm going to do the same thing on the vertical axis. So we're going to press the L key for line. I forgot to mention that before. Again, look for our little yellow or our little blue triangle, and that indicates we are halfway between the top and bottom points. You can see a blue square is showing up on the lines to show me that I actually have created a square line to the horizontal midline, and then again to the baseline. We do have our triangle indicating we are dead center on that, and so now I need to make that also a construction line. Again, you could press the X key, X is in Xavier, or press the construction button or icon over here. Either way works. But what this has done is given me a center axis line that I can work with. I don't really need the vertical, but if I'm going to do the horizontal, you might as well have the vertical too, right? So next thing I'm going to do is create a circle, and that circle is going to be for this hole right here. This whole design locates off of this hole, and the ID for this hole is a 6.75, and it is a tapered hole. And the tapered size of the hole is 14 millimeters on the outside diameter, 6.5 on the inside. The depth of this hole is 3 millimeters. And that was what you could see. You guys can totally see how horrible the drawings were. I went back and just scratched things out. 19.8 millimeters. Screw that. It's 20 millimeters. So again, hand measuring. Now, where do I place this hole? And this is what I was talking about. I didn't measure this base plate correctly because I have no way of locating this actual hole, and I'm going to actually turn off those X sketches because I don't use them. But I don't have a way of locating this hole. I do know it's on one of the center lines, and then if we open this image back up again, I know that the length of this channel is 60.7 millimeters. So that gives us something to work with right there. So we have 60.7 millimeters. If we say 61 millimeters, hooray. And then I know that the locate distance, if this is a circle, and I know it's actually an oval for the hole size, but if this is a circle, I know that the center of this circle is located about 18 millimeters from the center of this circle. So we have 18 millimeters from here to the center of this circle. This whole design is 60.7 millimeters or 61 millimeters. And then I noticed that this is a fillet edge. The top edge is a fillet edge, but I didn't do that in the 3D model because I think it's a waste. I'll give you the edges so it doesn't stab anybody, but the corners are not really that big of a concern. So I know that this edge to the outside edge of this hole is about the same as this one to this one. So when I did my model, that's kind of what I used as my basis. That's what I extrapolated, however you say that word. I'm tired. Anyways, so we're going to do a little bit of math here. So if we have we have a diameter for these two circles right here, these endpoints of this channel. The diameter of the circle is going to be the width of the channel, which is 16.5. So this circle is going to be 16.5 millimeters. And then between the two circles we're going to have, and they're also going to be on the center line. So I'm going to draw my first circle real quick right here, and that's going to be 16.5 right there. Yep, there we go. And I know that, oh, by the way, C is the circle quick key, and I'm going to press the D key, and that is dimension. So I'm going to click on the center point of the circle and then the edge of this wall, and that's going to bring up my dimension and will allow me to locate the circle. So again, I am dead center on the center line, and like I said, the zoom is backwards, but the center point is going to be, I think I said 18 millimeters? 18 millimeters, so that should be about my point right there, and we can always change that if I decide I put it in the wrong spot. I can fix that later. So 18 millimeters, and then again, pressing the circle key, or the C key, I'm going to create another circle, and we are again at 16.5 millimeters in diameter. Just like that. Now, dimension key again, center point of this circle, center point of this circle. Now, the distance between the circumference endpoints has to be 61 millimeters. So the dimension of our, or the diameter of our circles is 16.5. We're getting a radius from the outside circumference to the center points on both of these circles, but we're getting two radiuses, so we can do the quick math and just say 16.5 or 61 millimeters minus 16.5, and that's going to leave us with 43.5, and that needs to be the distance between the endpoints of our two circles. So we're gonna say 43 millimeters right here, and that locates automatically the second hole, or the second circle, which creates our channel. Later I will actually draw the lines to make this a channel that we can cut out, but I'll do that right before we actually create the depth for all of these cutouts. So I am going to relocate this again real quick, and then I know I'm kind of doing this backwards because this hole is what everything locates off of, but again, because I failed my measurement, we're doing things a little bit backwards. I know this location to this location is 18 millimeters, and this location to the outside is 18 millimeters, so that's what I'm doing. We're going to create another circle, which I'll create off the center point, but I think it's going to be a little bit off. And this circle was 6.75 millimeters in diameter, And dimension key again to this point right here is, hello, oh, nope, I know what I did wrong. So real quick, back out of that, and I'm gonna do it off of the center line. And again, 6.75 millimeters. And now dimension key to this point right here. We'll do that, and then we're gonna set that at 18 millimeters. All right, so now we are located, and you guys can see it's just barely off the center line, the vertical center line. And that's what I was talking about earlier. I think I actually reduced this distance, but it's not really important. This isn't the actual drawing that I'm using to do my print off of. It's more of how do you guys do it, or how do you guys replicate it. So here we go with that, forgetting all about that stuff. Now if we go back to our actual design over here on the other side, we have a 20 millimeter circle again on the horizontal center line, which all of these positions are on, and this is 20 millimeters right here. This is another one where I don't think I properly located these, or I did and the measurement was just way off, but I think I think initially I measured these out to be about 19 millimeters, so I may end up changing that going forward, but we'll find out. So back into Fusion 360 and C key again. This hole is 20 millimeters in diameter, and let it create, and then oops, D key for dimension to this point right here. And that is going to be, 19 millimeters right there. So we have our 3 centerline objects. These are the four, because right now these are 2 separate objects, but we have our 4 centerline objects. These are the easy objects to create, and unfortunately it is time to get rid of our construction lines because they're not going to do us any good anymore. But it's why we also create the construction lines, so we can know what to take out easier later. So I'm going to select that line, go ahead and delete it, and delete that line because we no longer need that either. And so now is the fun, not so fun part. I'm going to create some more construction lines because they're fun. I know that I have 3 of these 20 millimeter holes right here, so I'm going to, and all 3 of them are going to be 19 millimeters away from the center point of our center hole. So I'm going to run a line from the center point of the 20 millimeter circle to this inside hole, and then I'm going to create the center point for another one of the 20 millimeter holes, which is going to be 19 millimeters from the center point. And because there are 3 of them, and it's 360 degrees in a circle, I am going to set the angle of this line to be 120 degrees, right? Because 360 divided by 3, that's going to be 120 degrees for each, and then the distance from the center point of one circle to the next is going to, or from the center point of the drawing to the center point of the 20 millimeter circle is 19 millimeters. So we have that, and it gives us our nice angle line right here, which is really important. We do need that. And then it also specifies the distance. So if we hit our C key, we're just going to come to this endpoint right here and click, and then we can create our 20 millimeter hole, just like, and I'm hitting 9, aren't I? Sorry, I'm using an Oculus Rift, so it's not, I keep doing it. Something is not right. Something must be wrong either in the drawing. I'm using an Oculus Rift, so I can't actually even look at my keyboard. But that is a 0. You guys can probably make that out a whole lot better than I can because I have a screen door effect. But so here's what we're going to do. We're going to make this distance. Let's make it 21 millimeters, and that creates a little bit more of a hole. And 21 millimeters. Again, this is really the same process that I went through when I was doing the original drawing, which is, okay, how do I do this now? Because I didn't have the original design CAD drawing, so we're gonna hit L again for another line, center point off of here, and I'm just gonna tag this circle right here. Was kind of hoping I would get the easy way out, but I did not. So we want our distance is 21 millimeters, and we're going to hit the tab key. We're at negative 120. That is the equal sign. There we go. So I have 120 degrees. Oh, that is just very wrong. Very wrong. Fun. So we had set this to 21, just like that. And line from here. Oh, I know what it is. It's supposed to be negative 60. And that is distance. 21 is our distance, and negative 60. Enter. Which does give us our point right here, and I will explain that real quick. So, if this point right here is on our 0 or 180 line, all right, our horizontal line is going to be 0 and 180 degrees of the circle that is surrounding our center point. So if we go, we know that this hole, and what will eventually be this hole creates 3 points of a circle. That's going to be 360 degrees. So we're going to call this 0 just for funsies. And we're going to add 120 degrees to get to our next point, which is going to be right here, all right? This is 120 degrees. Now, to get to 180 from 120 is 60 degrees. So we're going to come 60 degrees, and we're going to be at our 180 degree point right here. Now, from this point to the next point in our triangle, which will soon be a circle, it's another 60 degrees. Half of 120 is 60 degrees, so we're going to go another 60 degrees, and that does create our third point. So it is 120 degrees from here to here, and from here to here, just by making that 60 degree mark. Circle key again, center point. We're already at a distance of 21. And this is going to be a 20 millimeter circle. And again, we are running into another problem. So I do know that these are located correctly off of this center line hole, but the distance from here to here is not working. So we're going to change our distance. We'll make them all 21. Huh, that was the wrong distance. Or was it? Did it get tagged somehow? It did. It must have gotten tagged somehow, which is funny. Alright, so we have to redo some of this. And I'm going to actually cheat, which I know is a horrible, horrible thing to do. But we're going to delete our distance line here, our distance line here, and then I'm actually going to get rid of the circle itself. Gone. And gone. So It did help me locate this point, so that's still useful for me. I just have to go back and recreate my other points, which is somewhat annoying, but it is what it is. Unless this angle is wrong. Because maybe this angle is wrong. That's a 40. You guys didn't tell me it was a 40. How rude. So that's a 60, and the rest of this is garbage. You don't need that. That needs to be 60 degrees. That's better. And now I feel like I wasted all that time. No! Really not that really critical important. So we're just going to hit the circle key again. Draw an abstract circle. Our diameter of this circle is 16.5. So we're going to do that. And then our distance from here to here, which I'm going to put out right there, was, I believe, 18 millimeters. So we got that. And then we had another circle. I better do a line since I got rid of my other drawing. So we're gonna escape out of that, turn this into a construction line, and go right back into another circle. Again, 16.5 right there. Confirm that. We'll set a distance. We had a distance before of 43 millimeters, so I got close. 43 millimeters. All right, and I really don't have to bother with oh no. Oh, that's messed up. I put the distance wrong. So okay, we're gonna delete that. Distance between center point and center point, and we're gonna drop that right there. We have 43 millimeters right there, and that's going to help better locate us. I'm not going to locate this hole on the sidewall. There's no point. They were originally located off that sidewall, and that's how we got this point, so we're all good with that. And I don't really have to play with that anymore. But next up is the other two channels. If we look at our drawing again, or our photocopy, this is what we have right through here. We've got two more channels, and you can see they're all equilateral. So we're going to come back to our fusion drawing, and we're going to create another line from the center point of our center hole, and this line is going to be 18 millimeters long, and we want the degrees to be about 120. Whoops. 18 1 2 0 off that center line. So we're coming there, and awesome, it's rendered. You can see right here we have 120 degrees from this construction line right here to this point, which C for circle again. We're going to draw out our circle, and that is again 16.5 millimeters in diameter. And we have overlap again. How do we have overlap again? That could be a distance problem. Distance is right. That's 60, like it's supposed to be. I keep coming back to this, but I think there is actually a problem. There we go. 60 degrees. I had typed 69. I'm wearing an Oculus Rift, so I cannot see my keyboard. I can't see my hands in front of me, and I'm gesturing. But I can't see the keyboard, so I can't even confirm the numbers, and then because of the screen door effect with the Oculus Rift, I can't actually read the numbers that well. Could also be a problem with my stigmatism, but hey, who's counting? One more time, we're going to run a line from the center point of our drawing. It is going to again be 18 millimeters out right there. and we want it to be, oopsie, tab 120 again off the line. So we have a 120 rotation this way, we have a 120 rotation this way, and that's going to give us our final circle diameter, C again for circle, and our diameter of this circle is 16.5. Now, all of these measurements are very convoluted. They're hard to read on the screen. They're hard for me to read anyways, but they're kind of all busy, and there's not really a whole lot I can do about that. I could, without specifying the distances, just draw lines and then specify a distance later, which would allow me, as you saw with these distance lines or dimensional lines, I can actually specify where those dimensional lines end up, but that's not so critical as the fact that they are measured out, especially when you go to do CAD designs. Being able to, well, I suppose it is important because being able to read the data in the CAD design is pretty important. Anyways, we're going to start out with our line tool real quick. We're going to go from the center point of this circle. We want to make sure that we stay in line with our original, and you'll see that it kind of has a black color right here, but if we stay in line with the original angle, we can come out and you'll see down there, or you see down to the left of the pointer, it does still say 120 degrees. And we're going to set this distance at 43 millimeters because this is to the center point of the end hole. Circle key again from that point, and again 136, no, 116 or 16.5. See, this is a problem. So we have the second hole for our second channel, and we're going to come up here and do our final hole. Again, we're going to hit the line key, which is L, center point, follow along the same line, 43 millimeters, just like that. And now we can hit our circle key again from that end point, and again 16.5. Awesome. So zoom is backwards. We have our fun little drawing that looks very interesting, very geometric and weird. But anyways, we have the circles for the endpoints of these two channels, just like, or for all three of these channels rather. We have these three circles, which I'm not really entirely sure what the point of these circles are, even in the final product. I still don't know, maybe weight reduction, but it is what it is. They're there, so I recreated them. Anyways, we're going to come back to our drawing over here, and we need to actually create the channels that you see in the other image. So I'm going to zoom back in, if I can remember how to do that ever. Nope. And we're just going to relocate ourselves so that we can draw a line from the center point perpendicular to our trace line. You can see a little blue square at the center point of the circle. That's showing me that the line is perpendicular to the line that we used to set the distance. Now I'm going to do that again right here. Again, I still have the little blue square. I do know that these are right angles right here. That's important. And I don't really have to do that on the other square, and I'll show you why. Because if I don't have to do L, I can just grab that line from that point right there, and all I have to do is verify down at the base of this line that there's a little blue square there. That's showing me that there's another right angle, which means by default I'm going to hit this other circle at the correct point, and I'm going to have a right angle right through here. Now I can come back over here and do the same thing. The only place that I can intersect this circle is going to create a right angle, or it won't create a right angle. So again, coming right here, and we have exactly what we need. Now for kicks and giggles, and I do have the right angle. It's very hard to see, but you can see the little teal blue square right next to the mouse on the right. So we did create successfully the right angle. No, we did not. Oh, I have failed. Nah, really not that big of a deal. But I should do it right, right? Alright, so line tool. And from here, right to there. And it ate it again. And to here. It's telling me it's snapping right there, like that's where it's supposed to go. So, and then again, it retraced. Funny. But here we go. All right, so we've created what we need to create, the shape that we need to create. I can go ahead and delete that line right there. It's not necessary. This component I can't delete. I've tried before, but every time I try to create or delete this inside line so that it's easier to extrude later, it just ends in failure. Maybe there's a way to do it. I don't know it. If you do know it, please comment below and let me know how I can fix that. Until then, we're going to go on to our next circle. And again, center line or a radius line off of the location line, 90 degrees. And we're going to mimic that again over here. And then from here all the way down to our circle until it snaps. That is kind of the advantage of the snapping, is it will handle it for you so that things can be more accurate. When it works correctly. Sometimes it doesn't always work, but real quick, I'm just going to snag this line out of here because we don't need that anymore. And one more. Doing it on the on a different circle now, but it's the same process. From here to here, you can see the right angle boxes that were indicated, and right there we make contact, perpendicular, and from here to here we go. And we do still have our construction line that we can snag out of there. Snag that. We can snag that construction line out. We didn't get that out, did we? Nope. Keeps taking an angle line out. I want to leave that. So we're going to get rid of that. I'm going to get rid of that. And this one. And these were just the lines that we used initially to locate our holes further out. I think I am going to leave them because they do look kind of interesting. Makes the drawing seem a lot more convoluted than it actually is. It's a really simple drawing. It's just got dimensions and specifications that make it look worse than it actually is. But anyways, so we have basically our shape. This is it. So I know that this has a step inside, but this hole, this hole, this hole, and the center of this hole go all the way through the device, so or through the base plate. So that's what I'm going to start with. I'm going to select this, and then I probably am going to have to zoom in on our center hole so I can actually select it correctly. It's going to make me multi-piece selected just like that, but that works. and zoom out again. Now the correct way to do this is to press our Q button again, and we're going to do offset plane. Flip this over to the bottom, and then we just click on the plane, and it automatically, you can see that it draws the holes all the way through the device, or through the base plate. That is the correct, proper, if you're doing this is how it's supposed to be done way. The other thing that you could do, which is not proper because if you change the drawing later, it might no longer apply. But the other thing that you could do is just draw it way below where you need to draw it to completely cut through the faceplate or whatever object it is that you're drawing. But this is an offset plane, so if I just click on the bottom side right there, it will cut the holes all the way through. We say okay, and look at that, we've got 3 holes all the way through our object. So I'm going to turn our sketches back on because we still have some more work to do. Come back to the top, and we are going to cut out these objects to the correct depth. Now this is the fun selecting party. There we go. Sometimes Fusion is easy to get objects to select, sometimes it's a little not. I understand that it's trying to be intuitive about what it's actually selecting, and so that does make things a little bit more difficult, I get that. But sometimes it's easy, sometimes it's not. Finish selecting our holes over here. And we can extrude these. So push pull tool, which is Q, and again, if we go back to our drawing, this step right here, the long step is 9.34. Now I think I made this 12.5 millimeters in thickness, so what I'm actually going to do is I'm going to create a depth of 9.5 millimeters, and I'm going to rotate this so that I do it correctly. But I can type this in, which is going to be negative 9.5, but there is actually a way that we could do offset plane again. So if we take this to 0 and we go offset plane, select this bottom again, and then see, it's automatically filling that in, but maybe I selected the wrong one, I can't remember. Nope, that's not it. It is offset plane, but it created the same thing, so there was another way to do it and I guess I forgot it, but negative 9.5 right there. So we have our depth of 9.5 millimeters, almost all the way through, but not quite. Have you guys figured it out yet? We have another channel down here. This is a step. So we got to cut some more holes out, create some more area to cut out. And yes, I know we still have these 2 holes. I'm not super concerned about that. I'll get to that in just a second. That's more for the devices that are bolted to the plate. Back into Fusion. Looking at the top face again, we are going to create some more circles. And go ahead and click on this face, center point of this circle. The diameter, not the diameter, but the hole width, or that channel width, is not on this one. It is on the other picture, which is right here. And that is 6.7 millimeters. There is an imperial measurement bolt that went through that hole. That's why we came out with 6.7. So this circle needs to be 6.7. There we go. Got to it eventually. And then I'm going to go ahead and get these holes out of the way as well. Got to be careful about which one of these I select. It'll make my channel a little off center. Circle key again, in the center on this the center point of this hole, and 6.7. All right. And it's the same process for creating the top part of the channel, with drawing the two endpoint circles and then the connecting lines. And I'm pretty sure there's probably an easier tool inside of Fusion 360 that would let me do this a whole lot faster. Maybe an oval tool that I haven't found yet. I'm still pretty new, but this doesn't take too much time. It just does take a little bit more time than it could if we had a faster tool. So zoom in again. Like I said earlier, the zoom tools are backwards, but we're gonna go from here. Again, we have our right angle line up there to watch out for. We are snapped, and that is one thing to be careful about, is where you snap, especially when the drawings get like this. There are tons of things to snap to, and that can cause problems for you. So be aware of what you are snapping to before you click on it, or your drawing is going to be just a little bit out. Again, make sure we're in the line tool. Oops, yep, we're in the line tool. And drop the line tool. So, see, that triangle is trying to draw me somewhere else, and I don't want that. I don't want it to be there. So, go into our here. And there, and we have one more set to do, and then we are good, and we can cut out our the last areas that we need to cut out. And if you've seen any of my videos before and you've heard music in the background, it's almost always been Electus in the background. And the same guy is in the background right now. That's actually Alan Watts, the motivational speaker, but the song that he put together that incorporates Alan Watts' voice is by Electus. He is a really awesome guy. So this is Seize the Day, of course. But going back to our drawing over here. So our final channel is 6.7 millimeters. And we can actually go back to our other picture, because that's the only measurement I needed off that page at this point. So we're going to start selecting our final channel for cut. And again, we're holding down the control key to select multiple items. Alrighty then. Gonna zoom out, make sure we are selecting everything that we need to select. We're gonna press our Q key again, and I've shown you guys offset plane. This is the bad way to do it. But now we have our geometrically correctly designed shape. Poorly designed shape is more accurate. So now, if I remember correctly, I think what I had done is that got convoluted quickly. I think what I had done is a line that was 71 millimeters. That's not really right, is it? So for these final two holes, which really are, again, not that important overall, they're important for my finished product, but even that could be done later. I think I must have estimated that the endpoint of this hole, or of this channel, must have been about equal with this hole right here. So you know what, I'll run with that. 60.7, we'll say 61. So I'm going to use my line tool, go from the center point of everything, 61 millimeters, hit enter, and from here to, oh, we don't have enough distance for that. So okay, so I probably made the build plate a little bit bigger in my other drawing. I'll change this distance to 51. That's fine. And line tool again from here out is going to be 20 millimeters, and that's important later, but not right this second. Extrapolating the distance, we're looking at about, let's see, 14 millimeters, so 7 millimeters plus 20 millimeters, 27 millimeters down. Let me show you where I came up with that number. The outside diameter of extrapolating information. So this filleted hole or tapered hole is 14 millimeters in diameter. Okay, remember the inside center hole is 6.7 millimeters, but the outside of the shaped hole is 14 millimeters. So half of that, which is going to be our radius, is 7 millimeters, because if we look right here, it's about even with the top of this circle right here. So we'll say that's about 7 millimeters to that hole. And the reason that's important is because if we look over here, the bottom of this hole is the bottom of this hole right here. It's about. Again, it was my fault for not properly extrapolating or properly measuring this out and locating these holes. But I do know that it's not, the positioning isn't super critical. From the finished device, I know these two holes aren't that important as far as how close they are. So we're gonna keep on rolling with that. So if the bottom lip is about even with that, and we know that the bottom lip of this hole is 27 millimeters from our center line, we have a diameter of this circle of 5.25 millimeters. Half of that I'm not really even going to bother with, just because I think it's kind of silly. So we're going to say that the bottom is 26.5 away from center line. Or I'm sorry, 2625 from center line. So that's going to put us at 24. The center point of this circle is going to be about 24 millimeters from center line. So we're back in Fusion 360 over here, and we're going to open up our line tool again. We're going to select this point, and we're going down 24 millimeters right there, and then again right over here. We could have done these with construction lines, but I did not. 24 will be precise. We're going to be precise, but we're not accurate. C for circle, and we had 5.25 millimeters in diameter. And again, C for circle, 5.25 millimeters in diameter. And remember how this line segment right here is 20 millimeters? That automatically is going to space these two holes 20 millimeters apart. But if I didn't want to use this line segment, what I could have done is created one of these two holes and then located this hole horizontally spaced 20 millimeters away, and it would have done the same thing just by using the dimension tool. Now that that's done, I can actually delete these lines. Again, they could have been made construction lines, but they weren't. And we need to create depth for these two lines, or for these two holes. So we're going to slide over here. And before we do that, I'm going to go ahead and run out Oh, it trashed all of my cuts. I mean, how cruel. So we're gonna have to re-extrude all of this, but that's really no big deal. More fun, more learning for everybody. Like I said, I'm still new to this. I've been doing 3D modeling for like a week, so I'm bad at it. Oh well. I shouldn't say I'm bad at it. I'm new at it. Oh well. And I'm going to have to zoom in some more so I can select that. And we're going to hit that and that and that. I'm selecting all of the objects which are going to be extruded all the way to the outside. Again, center or control key for multi-select. I had it. There we go. Got that. I don't need that construction line. I just accidentally snagged it. I gotta say, Electus's music is impressive to work with. Sometimes you want some really up tempo beats, but that makes my mind wander a little bit sometimes. So having some nice calm music is really helpful. If you guys have not checked him out, Electus is on Spotify. He's also on SoundCloud, YouTube, and Facebook. YouTube and Facebook, of course, is Electus Official, but you will find him as just Electus on SoundCloud and on Spotify. So everything that's going all the way through this base plate we have selected, and we're going to press our Q key again, offset plane, rotate to the bottom side, and we're just going to click on the bottom face and hit enter. And so we have cut our holes all the way through. Oh, and you can see it actually went back to the further drawing where it cut our channel out for us. So, but that's about it. We're really done at this point. We can hide sketches by just clicking the light bulb over there. We'll click top, and we're more centered on the screen now, and you can see we have our actual product. Now at work, I have a ForceForge Creator Pro. So if I click the Make button up there, select my object, it's automatically, and I click OK, it's automatically going to create my ForceForge or ForcePrint application. It's going to bring that up, and I can see what my model is going to look like right there, which is about what I want. Now when I click print, as you can see there are two red walls. When I click print, everything outside of these red walls is going to be cut off. It won't be there, but that's not really important. What is important is this design, and it's only semi-important that these holes are there because they could always be drilled after the fact. That's not even a critical marker. So this hole is not being fillet or tapered in the 3D model because the device that comes out of the metal base plate is bolted to this plate differently. So that's not there, if you were wondering. Now you know. If not, yeah, I wasn't either. Anyways, I hope that was helpful to some other new people. It wasn't perfect. It doesn't have to be. It's how we learn. You know, we make mistakes, we move forward, we do things a little bit differently. This took me a lot longer to kind of figure out how I was going to do it because of, or after taking what I've learned from some other tutorials. It was a little interesting. Like, it took me a minute to figure out how I could actually create these channels, as far as creating two circles and just connecting them with lines and then cutting out that whole shape. That was something that was interesting to me. I didn't initially think that through, but by the time I got to the point where I needed to draw those out, I just went, oh yeah, circles and lines, and that creates an oval. That just exactly what I need. So if you can't figure out something that you really want to do, look it up, look for a tutorial, think about it, be creative. You will find something or find a way to do it, and that's the important part. You don't have to know how, you just have to know how to find out how, and you'll be able to succeed. So I hope that was helpful for people. If it wasn't, then don't be afraid to leave a comment and tell me that was boring and lame and you should never do that again. If you liked it, awesome. I'm glad I could do something to help you or be useful. I like learning new things, so I hope you do too, and if so, then stick around because I'll be around. This isn't what I usually do on the channel, but I will be doing some more of this stuff later. Because I'm really a car guy, and one of the things that's fascinated me about 3D modeling is I can make things that I can't find somewhere to buy. So like, this is the perfect little way to fill this niche. And wow, okay, it's not that bad. I did an hour and 10 minutes by the comment marker here, so we're probably a little over that as far as length of this video, but I'm not super concerned. Wow, I'm gonna have to edit the information. I hate when it does that, but it is what it is. You guys can see what kind of computer I have. I don't like it because I think it makes it look messy, but I'll edit that information so you guys don't know what my computer is. Haha. Now, if you want to know what my computer is, feel free to leave a comment. You can tell me it's a crap computer if you want. I like my computer. It does what I need, and that's what the important part is. I will say that engine that I told you, or that I kind of leaked information about, that engine is going to be ordered this coming Friday. So super excited about. And I want to be quiet about it because it's going to be really awesome, but I haven't told everybody what's going on. And I like surprises, and yay! So you guys are going to be somewhat surprised. Maybe somebody's figured it out. Maybe others of you don't care. I care, so it's important to me. And you're on my channel, so haha. Anyways, leave a comment, guys. Let me know what you liked. Let me know what you hated, and I'll think about making some improvements or some changes. I probably will, though, if you guys really don't like something. So don't be afraid to share your feelings and let it all out. I will be coming back. There's some other videos that I would like to do. I'd like to do some Quora videos. Just some daily. I'm a member on Quora. I don't do it for profit or for money or fame or anything like that. As a matter of fact, I haven't even filled out most of my profile information, and it's been like that for like a year, over a year, since I've been a member of Quora. I've just left it blank, and if people accept my answer, they accept my answer. But I'm getting to the point where I get a daily digest now of things that I might find interesting, and Quora's right for most part. It sends me a bunch of questions and answers about Game of Thrones. I don't care about Game of Thrones. I don't like it. I don't hate it. I've never watched it. I have no interest in watching it. But for some reason, Quora thinks that I like it, and it's Google's fault, because I looked up the slogan for the Night's Watchman. In the access control department that I work for, the previous head of the department had used their little mantra, I guess, the Night's Watch mantra, and I had asked him where those lines came from, and he explained it came from the lines from the Night Watch from Game of Thrones. So one time I searched anything Game of Thrones related on Google, and now I get a bunch of questions on Quora, and it's like, I don't care about these things. How do I make it stop? But a lot of times I do get some fairly interesting questions. The other day I got one. That is, there are 100 switches. Half of them turn on, every other switch turns on, and then every third switch changes state. So if you don't know what that means, what is on turns off, what is off turns on. So 100 switches, every other switch turns on, or every second switch turns on, and then every third switch changes state. How many switches are in the on position? Let me know in the comments below what your answer is, and I will see you guys another time. I hope you, again, enjoyed this video, and if not, then I failed you. I have failed you miserably, but I will be back to probably do it again, but it is what it is. Love you guys. Bye.